Okay, so this says lesson 2 and it says day 2, but we're doing it all sort of together. There's not much difference except the algebra. So again, we're going to talk about the roots. And what the roots mean are, those are the values of x. Maybe you should know this. The values of the variable that make, now in math terms we'd say satisfy, that make left-hand side equals right-hand side. Okay? So that's what a root is. It is the value of the variable that'll make the left-hand side equal the right-hand side. So the roots of a quadratic equation in this form can sometimes be found by factoring. And the roots can always be found using the quadratic formula. So let's see what we get here. Solve each of the following. Well, you got to do a little bit more algebra. That's all. So what you're going to do is you're going to expand this. X squared negative 6x plus 9 equals 2x plus 2. X squared minus 8x plus 7 equals 0. So you needed to get this into standard form first, always. Now, two numbers that multiply to give 7, add to give 8. I'm thinking 1, and I'm thinking 7. They multiply to give a positive, so one's positive, they're both positive or they're both negative. Let's check if it works. X times x is x squared, negative 7x, negative 1x, negative 8x, plus 7, it works. Notice the 0 stays. All I did was factor this. And so I've got two terms that multiply to give 0. So either the first one is 0, in which case x equals 1, or the second one is 0, in which case x equals 7. Pretty straightforward. Let's do this one. So this is going to be x squared minus 6x plus 9 equals 8 minus 2x squared plus 1. Notice that that 2 only goes into the brackets. It doesn't leap over to the 1. Okie dokie. Bring this over here, so it's 3x squared. It's negative 6x still. That's 9. Bring that over. It's 9 take away 9. I guess it's 0. Let's see if it can factor. If it can factor, then I'm going to want to solve it by factor. Notice here I factored it because it's faster. I could have used the quadratic formula, but because it factored, it was easier to do this way. This one, I'm going to common factor out of 3x, which leaves me with two things being multiplied to give 0. So either 3x equals 0, in which case x equals 0, or x minus 2 equals 0, in which case x equals 2. And I'm done. Excellent. So factoring's cool. It works. Remember, you need to get things in standard form first. Then we factored, if possible, because it's faster. Factoring's faster than using the quadratic formula. Okie dokie. Now there's a grade 11 question. There's a grade 11 question. Now there's a couple ways we can handle this. We can get a common denominator here and then multiply both sides by the common denominator, and that would be fine. The other thing that we can do is we can multiply each and every term by the LCD to eliminate the fractions. I tend to do that. So what I'm going to do, take a look at this. I'm going to write it. What I've done is I've multiplied by the LCD here, and there's a reason for it. And notice it's the same as multiplying. I've multiplied each and every term, which is the same as multiplying the entire left-hand side by it and multiplying the entire right-hand side by it. But look what happens. I've now created a new question. Well, it's the same question, but I've rewritten it. They're equivalent. Now I'm going to expand. Now this negative has to go into the 2x and the 4. So it's negative 2x and it's negative 4. Be careful of that. This is going to be probably easiest if I do x squared plus x plus 2x plus 2 times 3. This will be negative x minus 3 equals 3x squared. I bring the 3 over. Now this x plus 2x will be 3x times 3 will be 9x. And that'll be 6. I may have skipped some steps that you need to put in. Now, this is positive. I like this positive, so I'm going to bring these guys over. 3x squared plus 10x, this one comes over, and plus 9. Now I'm going to try to solve it by factoring. So I get my piece of paper, and I'm going to rewrite it. And I'm going to look at this for a minute. Two numbers that multiply to give 27. That's going to be 1 and 27. 2 doesn't go evenly. 3 and 9. And what about 4? No. 5. No. 6. No. 7. No. 8. No. 9. Yes. Neither of these two or those two will go together to give me 10. This does not factor. It doesn't. It can't. Neither these two nor these two can go together to give me 10. So I can't factor. So use quadratic formula. Okay? So I'm going to have to come way over here. And to save some room, see how I've got it equal to 0. Notice that my variable is x. X equals negative b, so it's minus 10, plus or minus square root, b squared, which is 100, minus 4 times a, which is 12, times c, which is 9. So 12 times 9 is 108. Over top of 2 times a is 3, so it's 6. And that's the way I expect grade 11s to be able to handle this. You're going to go straight from there to there, and you're going to get it right. X equals minus 10 plus or minus square root negative 8 over 6. Now that is 4 times 2 times negative 1. So it's negative 10 plus or minus, the 4 comes out as a 2, the negative 1 comes out as an I, and you're left with a 2 over top of 6. Now that's 6, see this 2 and that 10? We can common factor out a 2. So it's negative 5 plus or minus I root 2 over 6. And finally this 2 and that 6 will reduce, giving me minus 5 plus or minus I root 2 over 3. And that is your final answer. And there's two answers there. There's negative 5 plus I root 2 over 3, and there's negative 5 minus I root 2 over 3. Okay, let's flip that over. And your homework. Solve each of the following quadratic equations by factoring when possible. Or solve to the nearest hundredth when factoring cannot be used. So you're going to have to actually figure out and use your calculator. Now none of them will have i's in them if you're doing to the nearest hundredth. So none of those will have i's. But you're going to have to be able to figure out the decimal equivalent of something like this. 2 plus or minus 5 root 3 over 1. Let's get rid of the 1. Let's make it over 3. Okay? So you're going to have to figure out how to use your calculator to do that, and your calculator to do this. And each calculator is different, and so make sure that you're able to convert those into the decimals, whatever they are. The first one, well, it doesn't matter what they are. You be able to work on them, check with the back of the sheet, and if you get them wrong, then you're doing something wrong with your calculator. So I'm thinking we can do all of these. I'm thinking we can do all of these on this side, so we'll do all of those, and I think you can do all of these. And we'll save the others for more practice later. Okay guys, so this has to be done for class on Wednesday, and I'm moving on from there.